So, you've heard the story, right? The future of AI is all about these incredible autonomous agents and just unstoppable exponential growth. But what if that story is only half the picture? Behind that slick curtain of hype, there's a very different, very physical reality taking shape. Today, we're going to pull that curtain back and look at the operational truths, the invisible infrastructure, and, yeah, the secrets the industry would probably rather you didn't think about too much. This is the story we're sold, this sleek, beautiful rocket of progress just soaring into the future. But look at what's really going on here. That rocket is bolted onto a massive, complex, and honestly kind of grimy industrial machine. The real story isn't some kind of disembodied magic happening in the cloud. It's about nuts and bolts infrastructure. And that right there is where the real challenges and the secrets are hiding. And this slide just lays out that disconnect perfectly. On one side, you have the public narrative, the hype. AI is getting exponentially smarter. It's going to save us all time. And of course, our data is totally safe. But then you look at the operational reality on the ground. Labs are hitting a hard performance wall. AI is actually creating brand new types of human work. And oh yeah, your prompts, they're absolutely being logged and used to train the next model. So, what is going on here? What's causing this huge disconnect? Well, it turns out the entire industry is running headfirst into three fundamental hidden walls that are really changing the whole game. Let's break them down. First up, we've got the scaling wall. For years, the mantra in AI was so simple. Bigger is better. Just get more data, throw more computers at it, and boom, you get a better model. But that's not working anymore. Now, labs are finding that doubling their already massive investments, we're talking hundreds of millions of dollars, is only giving them these tiny fractional gains in performance. The whole brute force era, it's coming to an end, fast. Now, here's a really dangerous side effect of hitting that scaling wall, something called model collapse. See, as we start running out of high-quality, human-written text on the internet to train these things, labs are turning to AI-generated or synthetic data. And the risk there is huge. You create this feedback loop where an AI starts learning from another AI's mistakes, amplifying all the weirdness and flaws until the quality just tanks. It's kind of like making a photocopy of a photocopy of a photocopy. Eventually, you're just left with a blurry, distorted mess. This second big barrier is what people are calling the ghost work backbone. This idea of a fully autonomous AI is super compelling, but the truth is these systems are propped up by a vast global workforce of actual human beings, people who are completely invisible to us as users. These are the folks manually labeling data, fixing the model's weird or embarrassing outputs, and providing all that critical feedback that makes an AI feel so polished and smart. And this process is usually called reinforcement learning from human feedback, or RLHF. Here's basically how it works. First, you have actual people rate and rank a bunch of AI responses. Then, a whole separate reward model is trained to just predict what the humans are going to like. And finally, the main AI model you talk to is fine-tuned to do whatever it takes to please that reward model. So that helpful, friendly AI assistant you're interacting with, its entire personality was painstakingly shaped step by step by thousands and thousands of human judgments. And that brings us to our third wall. And this one might be the most solid of all. The physical constraints. AI isn't just software living weightlessly in the cloud. It is a thermodynamic challenge. A single large AI data center can guzzle as much electricity as a small city of 100,000 homes. This isn't some far-off theoretical problem. It's a real-world, grid-level bottleneck happening right now. And this incredible thirst for energy has huge geopolitical consequences. As you can see here, nations are now treating high-end AI chips like strategic assets, almost like oil reserves. It's leading to these sovereign AI initiatives. At the same time, companies are scrambling to shift from general-purpose GPUs to hyper-specialized chips just to squeeze out a tiny bit more efficiency. But at the end of the day, the growth of AI is now directly limited by something as basic as the capacity of a regional power grid and its access to water for cooling. Okay, so we've got a scaling wall, a human labor wall, and a physical power wall. These are massive, massive constraints. So, with all that, where is the real competitive advantage in AI today? It's not the algorithms, not anymore, and it's not even who has the most hardware. The real moat, the one true secret weapon, is data. This quote just says it all, doesn't it? Data quality beats algorithms. The biggest breakthroughs we're seeing aren't always because of some revolutionary new model architecture. More often than not, they're the result of painstaking, proprietary work on the data itself.
A smaller model trained on exceptionally clean, well-curated data can easily run circles around a giant model that was just trained on the raw, unfiltered chaos of the web.
And data curation is truly an art form. It's about filtering out all the toxic junk, deduplicating repetitive information so the model doesn't just get lazy and copy things, and then carefully augmenting the data, mixing different sources together to teach it very specific high-value skills. This process, this art, is one of the most valuable and most secretive parts of any AI lab's IP. This is the secret sauce. It's why one model sounds brilliant and insightful, while another just sounds generic. So, if brute force scaling is hitting a wall and data curation is the real secret weapon, how is the industry actually responding? Well, they're shifting their entire focus to a brand new frontier: efficiency. And this right here shows you the fundamental pivot that's happening. We're moving away from the old mantra of bigger is better, just raw scale, more parameters, more compute, and into a new reality where smaller is smarter. The new focus is all about optimizing a model's architecture, being incredibly efficient with that precious high-quality data, and building complex systems called agentic workflows. A perfect example of this new, smarter approach is a technology called retrieval augmented generation, or RAG. Think of it like this. Instead of trying to cram all the world's knowledge into one gigantic, expensive model, you connect a smaller, more efficient model to an external knowledge base. So before it answers your question, it does a quick search to look up the relevant up-to-date facts. This makes the whole system more accurate, way easier to update, and it cleverly sidesteps that whole scaling wall problem. It's not a single monolithic brain anymore, it's a smart pipeline. And you know, this massive shift in strategy is also causing a huge shift in talent. The heroes of this new era aren't just the research scientists dreaming up new algorithms. The most valuable players now are what people are calling performance architects. These are the engineers who specialize in optimizing every single part of the system, from the data pipeline to the custom hardware, all to squeeze every last drop of performance out of these massive, constrained systems.
So we're left with this final question. We started this whole thing by peeling back the curtain on all the AI hype, and what we found underneath wasn't some big conspiracy. It was a maturing industry that's finally grappling with real-world physical limits. So maybe the future of AI is less about that endless pursuit of magic and a lot more about the difficult, brilliant, and absolutely necessary work of mastering the engineering of constraints,